Hey Harper, Mimi told me you called, and I'm happy to hear you're enjoying school and doing well there and looking forward to getting these letters. Well, let's begin. We're going to begin in the cosmos because everything began there. Now, as we begin, I want to remind you of something. You are considering two competing explanations for why things are as they are. The materialist hypothesis says that everything we see, literally everything we see, is the result of purely natural causes. Now, people in this camp believe that someday science will provide a comprehensive explanation based on strictly natural causes and effects. The theist hypothesis says that an intelligent mind created the universe and established the laws of nature, and from time to time inserted new levels of complexity into those systems. Now, another way to express these two opposing hypotheses is to ask this question: what is the prime source from which everything else comes? The materialist really does not have an answer yet. They believe they will someday, and that whatever that answer turns out to be, it will not be God. The theist says that the prime source is God. So for now, think of yourself as a detective at a crime scene. You've arrived after the fact, you didn't see anything happen, and there were no eyewitnesses. But there is plenty of evidence to sort through. With each piece of evidence, you're asking the question, is it more likely that this was caused by natural events? Or is it more likely that this was caused by an intelligent mind? Well, the two images that you've just seen are only lines in the sand. But it's easy to conclude that one was caused naturally and the other by an intelligent mind. Okay, right now I want to show you a couple of videos.
Did the universe have a beginning, or has it always been here? Until Albert Einstein came along, this question seemed beyond the reach of science. In 1915, Einstein revealed his masterpiece, the general theory of relativity. For the first time, scientists could get to grips with how the entire cosmos behaves. Einstein believed that the universe is unchanging and eternal, but scientists realized that his new theory suggested something worrying. The universe is unstable. It must be expanding, or else it would collapse under its own gravity. In 1929, American astronomer Edwin Hubble made a dramatic discovery. Building on work by Henrietta Swan Leavitt, he realized that wherever he pointed his telescope, distant galaxies appeared to be rushing away from us. The further away they were, the faster they moved. Einstein was astounded. The universe really was expanding. Rewinding the history of the universe, astronomers realized this meant that every galaxy, star and planet must have once been squashed into a single tiny point. From this one point, the universe had begun as an awesome explosion of space, time and energy, the Big Bang. This controversial idea divided the scientific community in a debate that raged for decades. The decisive evidence would come from an unexpected source. In 1964, two American astronomers, Arno Penzias and Robert Wilson, were working with a super-sensitive radio antenna when they came upon a mysterious buzz. They tried everything to get rid of it. They checked it wasn't coming from radio stations in New York City. They checked it wasn't from our own galaxy. They even dismantled the entire antenna and evicted some roosting pigeons. But no matter what they did, the buzz remained. Finally, after puzzling it over with some colleagues, they came to an incredible realization. The buzz was predicted by the Big Bang theory. It was the faint remnants of light from the burning fireball in which the universe was born. That buzz, known as the cosmic microwave background, is the oldest light in the universe. Launched by NASA in 1989, the Cosmic Background Explorer made the first map of this ancient light, revealing a snapshot of the universe when it was just 380,000 years old. With this last piece of the puzzle, the debate was finally settled, and the Big Bang became the accepted theory of how our universe began.
Well, almost everyone would agree that Einstein was a genius, a brilliant person. But he was wrong in his original belief that the universe was eternal. Now, all of us make mistakes, and so it's always a good idea to remain a bit humble, since new information can sometimes prove us wrong. Well, next we're going to watch an interview with Dr. Wendy Friedman. Dr. Friedman is the director of the Carnegie Observatories in Pasadena, California, and also Las Campañas, Chile. She is professor of astronomy and astrophysics at the University of Chicago.
Wendy, how do we really know there was a beginning to the universe?
What we've been able to measure is that the universe is expanding. We see that galaxies that are more distant are moving away from us faster and faster. This was a relationship discovered by Edwin Hubble in 1929 in the context of Albert Einstein's general theory of relativity. What this allows us to do is to essentially run like a movie running backwards and say, okay, how long then has that expansion been occurring over? And so if you extrapolate back, you get to a time when the universe would have been much denser, much hotter, and a time we refer to as a Big Bang origin for the universe.
Now, is that the only technique that we know, or are there other techniques that can come to the same realization that there must have been some kind of beginning?
Well, we see, for example, if there had been a Big Bang, an explosion sometime early in the universe, you ought to see the remnants of the radiation from that Big Bang. And we do see that. You can predict, in fact, that it would be cooler now because the universe has been expanding in the intervening time, and we see the uniform background radiation. Now it's 3 degrees above absolute zero, very cold temperature, but we see it everywhere over the sky, which is evidence for an earlier fiery beginning to the universe.
So we really now have two totally independent sources of data. One is this expansion of the universe. We run that movie in reverse. The other is the remnant radiation that, since it's from everywhere, had to be from everywhere, and so that's the proof of that there was a beginning. So you have two totally separate pieces of data.
In fact, there are more. You would predict that when the temperature was really hot in the early universe, you would form the elements, light elements like hydrogen and helium, and you can predict very accurately what the relative abundances of those elements would be. When we go out and measure those abundances, they fit precisely with what you would expect if there had been an early beginning in a Big Bang.
And how about looking at the individual components within the universe, age of galaxies, stars, rocks on Earth? How do they correlate?
They're consistent. So when we measure the ages of the rocks on Earth, they're 3-4 billion years old. If we measure the ages of stars in our Milky Way galaxy, they have a range of ages up to about 12 or 13 billion years. So we have independent clocks that can give us estimates of the age of the objects that we see in the universe, and they are consistent with the same timescale that we measure by measuring the expansion.
So individual components, which may have formed at different times in the universe, all had a beginning, so that each of these independent pieces of information, even though their numbers may differ depending on when they formed, all cannot be explained without assuming that they began at a certain point.
Right. And you, of course, can't have objects in the universe that are older than the universe itself. That would be a contradiction. And so all of these timescales are, in fact, with now recent discoveries. So I don't want to get into dark energy, right? This is not the right time. But all of these measurements are consistent with an age of the universe of about 13, 14 billion years old.
While it was firmly established in 1929 that the universe was expanding, it took nearly 30 years for the entire scientific community to acknowledge this new fact. I wonder why. Well, I suspect it took a long time because this discovery had strong theological implications. You see, if the universe was not eternal, then it had a beginning. And to have a beginning, there had to be a cause. Now, here's the point that's really almost impossible to get your head around. All the galaxies, all the burning stars, 1 billion trillion of them, all of these were at one time smaller than a pinpoint. And before that first billionth of a second, there was nothing. Absolutely nothing. Not even empty space. Just nothing. So how did nothing become something? And whatever that something was, how did that turn into the everything that we see around us today? Dr. Michael Strauss from the University of Oklahoma has made an interesting observation about this event. Here's what he had to say. The second law of thermodynamics is true throughout the universe. But what people miss is that this law says that the universe was most ordered the instant after creation. It becomes disordered with time. An explosion does not result in order, but rather chaos or extreme disorder. How or why was this explosion so orderly? Well, an orderly explosion is something we'll talk about when we get into physics in another letter. Right now, I'd like you to watch 2 short videos that describe what scientists today believe about the early formation of the universe and the Earth.
The universe is everything, from the tiniest particles to the largest galaxies, to the very existence of space, time, and life. But how did it all begin? The origin of the universe is the origin of everything. Multiple scientific theories, plus creation myths from around the world, have tried to explain its mysterious genesis. However, the most widely accepted explanation is the Big Bang Theory. The Big Bang Theory states that the universe began as a hot and infinitely dense point. Only a few millimeters wide, it was similar to a supercharged black hole. About 13.7 billion years ago, this tiny singularity violently exploded. And it is from this explosion, this bang, that all matter, energy, space, and time were created. What happened next were 2 major stages of the universe's evolution. Called the radiation and matter eras, they're defined by key events that helped shape the universe. First came the radiation era, named for the dominance of radiation right after the Big Bang. This era is made of smaller stages, called epochs, that occurred within the universe's first tens of thousands of years. The earliest is the Planck epoch. No matter existed in the universe at this time, only energy and the ancestor to the 4 forces of nature, the superforce. At the end of this stage, however, a key event occurred in which gravity split away from the superforce. Next came the Grand Unification epoch, named for the 3 remaining unified forces of nature. This epoch ended when one of those forces, called strong or strong nuclear, broke away. Then, the inflationary epoch began, during which the universe rapidly expanded. Almost instantly, it grew from the size of an atom to the size of a grapefruit. The universe at this time was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last two forces, electromagnetic and weak, finally split off. During the next stage, the quark epoch, all of the universe's ingredients were present. However, the universe was still too hot and dense for subatomic particles to form. Then, in the hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, the radiation era's last two stages, the protons and neutrons underwent a significant change. They fused and created nuclei, and in doing so, they created the first chemical element in the universe, helium. The universe's new ability to form elements, the building blocks of matter, cued the matter era. Much as the name suggests, the matter era is defined by the presence and predominance of matter in the universe. It features three epochs that span billions of years, the vast majority of the universe's lifespan, and includes the present day. The first was the atomic epoch. In this stage, the universe's temperature cooled down enough for electrons to attach to nuclei for the first time. Called recombination, this process helped create the universe's second element, hydrogen. This hydrogen, along with helium atoms, dotted the universe with atomic clouds. Within the clouds, small pockets of gas may have had enough gravity to cause atoms to collect. These clusters of atoms, formed during the galactic epoch, became the seedlings of galaxies. Nestled inside those galaxies, stars began to form, and in doing so, they cued the latest and current stage of the universe's development, the stellar epoch. The formation of stars then caused a tremendous ripple effect and helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe. In turn, those elements became the building blocks for planets, moons, life, everything we see today. This ecosystem of everything was only possible because of the many stages in the universe's development. While countless questions about the origins of our universe remain, it's only a matter of time for some long-sought answers to emerge. Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, and the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
Well, obviously, a short video will necessarily be short on details. But one point that the videos clearly make is this: the universe did not spring into existence fully grown. It proceeded through a number of stages, progressing slowly from stage to stage, until we find it in its current form today. So let me try to draw a parallel with something that you might be a little more familiar with. Have a look at this video of a construction project. Well, did you see the similarities? We began with a blank canvas. In this case, it was a vacant lot. and proceeded through what appeared to be many unrelated and even chaotic activities. But none of those activities, none of those parts and pieces were accidents. They were all carefully planned and choreographed well in advance. There was a designer behind the design, and that person knew exactly what the finished product would look like, even before the first shovel of dirt was moved. The image you're seeing now comes from NASA. It's their idea of how our universe formed and changed over time. I think we could say that this is a picture of a construction site on a God-sized scale. Millions of stars formed and died to build the elements that were needed to construct the perfect home for humans. Now, did you notice in the video on the formation of the Earth how scientists now believe that the early Earth was covered with water? Remember this interesting point. It will be a point made in another letter a bit later. Well, there's more we could say on the subject, but here's the summary. An immeasurable amount of energy appeared out of nowhere. That energy became matter, and that matter built the cosmos as we know it today. Now, these facts have made a big impact on many cosmologists. I'd like for you to hear from just three. Arno Penzias was one of the two that discovered the cosmic microwave background radiation. And here's what he says. Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan. Richard Jastrow was a NASA scientist and the first chairman of NASA's Lunar Exploration Committee. Here's what he said. Astronomers now find they have painted themselves into a corner because they have proven, by their own methods, that the world began abruptly in an act of creation to which you can trace the seeds of every star, every planet, every living thing in this cosmos and on Earth. And they have found that all this happened as a product of forces they cannot hope to discover. That there are what I or anyone would call supernatural forces at work is now, I think, a scientifically proven fact. And Alan Rex Sandage, he was one of the American astronomers who determined the first reasonably accurate values for the Hubble constant, along with the age of the universe. He said, "It was my science that drove me to the conclusion that the world is much more complicated than can be explained by science. It is only through the supernatural that I can understand the mystery of existence." Well, hardcore materialists have as yet no material explanation. They live by faith today that one day there will be a verifiable natural explanation for the beginning. In my next letter, we're going to see how geologists have determined the age of the Earth and why they have high confidence in their numbers. Well, okay. That's it for now. Thanks again for calling. We love to hear from you, and I'll send the next letter as soon as I can. I love you.